This is day 12 of Unit 9. We started today with this warm-up, so pause and do the warm-up and then play to check your answers. So in this one, I'm noticing that the n plus 1 is the larger number, so I'm going to start in the denominator. So start with n plus 1, then 1 less is n, and then 1 less is n minus 1, and I'm noticing now that that's going to be a common factor with the numerator. So I'm going to factor that common factor out. I'm left with 1s in their places, and my final answer then is 1 over n times the quantity n plus 1, which if you want to multiply that out, you can, but you don't have to. Now I need restrictions, so what causes the restriction would be the 1. It's the whatever was the common factor, so the n minus 1. So that means that the restriction is n is greater than or equal to 1. That's my answer. Number 2, we have this governing board with president, vice president, secretary. The order matters and we can't repeat people, so that's going to be a 5p3, which is 5 factorial over 5 minus 3 factorial, which is 5 factorial over 2 factorial, which is the 2 factorials are going to cancel out, so 5 times 4 times 3, which equals 60. Or if you didn't use the formula, you could have just made a decision chart. 5, then 4, then 3, multiply gives us 60. Either is fine. Okay, so then for class, we used pretty much the same problem, except for now they're just on a committee and they're not in specific offices, which means that this is what we call a combination. The order does not matter. Okay, with a combination, the order does not matter, but also still no repeats are allowed. Remember, with permutation, no repeats were allowed. Same thing with combination, no repeats are allowed. So if those two things are true, then it's a combination. So what we're going to do is we're going to calculate 5C3. Now, with the n and the r, the n is still the number that you're picking from. The 3 you're just picking. It's the number that you're picking, not in, remember with permutation, it was picking and arranging, choosing and arranging. Now we're just choosing. So we're going to talk about what the formula is here in a second, but before we do that, we're actually just going to make a list. So I purposely used A, B, C, D, E for their names. So we're going to make a list and we're going to be organized with our list. So I'm going to start in order. A, B, C is going to be my first one, with choosing from the 5, choosing 3. Now keep in mind, A, B, C, that's the same committee as BAC and CBA and CAB. So I'm not writing all those orders. I'm just writing A, B, C. It only counts as one committee. So now I'm going to be systematic here. So I'm going to keep the A and the B, but I'm going to move on to D. Similarly then, I'm going to keep the A and the B and I'm going to move on to E. Now I've exhausted all my AB, so I'm moving on to AC. So A and then C, D, and then keep the A and the C and change to E. So that takes care of all the that takes care of all the A's, right? Because I can't, yep, looks like we can do AD. So we have A, D, E. Now that takes care of all the A's. So now I'm ready to move on to B's, and I'm going to do B, C, D, and then B, C, E. That takes care of all the BC's, so then B, D, E, and lastly C, D, E. Okay, I think we have them all. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10. Okay, so then we talked about in class why we're only getting 10 when we did 5P3 in the warm-up, we got 60. And hopefully you're realizing that with the 60, that included, now if I'm just looking at this first group, ABC, that included ABC, BAC, CBA, CAB, all those different arrangements of those letters A, B, and C. And in here with the committee, that's only one group. So instead of being many groups, now it's only one. So that's why this permutation is larger than combination. And when you have the same numbers for N and R, the permutations will always be larger. Now, then we talked about why, or not only is it larger here, 60 versus 10, but how much larger. And in this case, if I look again just at the ABC and I figure out how many ways to arrange A, B, and C after they've been chosen, well, I could make a decision chart for that. And we did this the first day of the unit, or the second half of the unit. So the 3 letters have already been chosen, so my choices for the first letter are 3 and then 2 and then 1. Well, that's 3 factorial, and that equals 6. So that's how many ways I can arrange those letters once they've been chosen. This 60 is how many ways I can choose and arrange. And this 10 is how many ways I just choose, not arrange. So what we want to do, hopefully you're realizing this, is we're going to take the 60 and we're going to divide it by, which is the number of ways of choosing and arranging. We're going to divide it by the number of ways of arranging, which is 6. And that'll tell us 10, which is the number of ways of just choosing. So we have choosing and arranging divided by arranging will give us choosing. Okay, and that works not only with these specific numbers or with this specific problem. We did 5p3 and we divided it by 3 factorial, and that gave us 5c3. So in general, npr divided by r factorial is going to be equal to ncr. So that you want to know. Now, that formula was one thing we talked about, and that's what we used here. But also, sometimes you're not going to know the permutation. Like in this one, we already knew 5p3, so it was nice and easy for us to divide by 3 factorial. But sometimes, let's say we had just done this problem and we hadn't done the one before it with the 5p3. Then I probably wouldn't use this formula because I don't know what 5p3 equals. So in that case, I would use a slightly different formula. So it looks like this: n factorial over n minus r factorial, and then it's going to be multiplied by r factorial. Now, you're probably saying, well, that looks kind of familiar, and if I can change colors here, this part, well, it was supposed to be red. This part that I'm highlighting in red, that is our NPR formula. And hopefully you're seeing that I can divide NPR by r factorial to get NCR. Well, that's what I'm doing here. This is the NPR, and if I multiply by 1 over r factorial, which is what's happening, that's the same thing as dividing by r factorial. So if I put this whole thing together, that is the combination formula. And if I look at just this one piece here that I have highlighted in red, that's the permutation formula. So the permutation formula divided by r factorial is the combination formula. And the permutation formula times 1 over r factorial is also the combination formula. So there's our formula. So this one, California Lotto, 51 numbers to choose from. We're choosing 6, and first we need to decide, can we repeat? Hopefully you're realizing when those balls come up in the machine, there's only 1 ball per number, 1 number per ball. So no, the numbers don't repeat. And then there was confusion about this in class, but hopefully you realize with a lottery, the order does not matter that I get the numbers in. If I have the number 5 on my ticket and 5 comes up, it doesn't matter where I picked the number 5. If it was the first number I picked, but it was the third number that came up in the machine, that doesn't matter. What matters is that 5 came up and that I have 5 on my ticket. So order does not matter and no repeats. Therefore, this is a combination. So 51C6 is what we're doing. Now, we don't know what 51P6 is, so we're not going to use that first formula. We're going to use the second one, which says 51 factorial over 51 minus 6 factorial times 6 factorial, which gives us 51 factorial over 45 factorial times 6 factorial. And I'm realizing the 45 factorials are going to factor out, so I'm left with 51 times 50 times 49 times 48 times 47 over 6 times 5 times 4. Oops, it looks like I need a 46 as well. The 45s are going to cancel out. 6 times 5 times 4 times 3 times 2 times 1. And when I do that, 51C6 is 18009,460. So 18,009,460. Okay, whoops. So next example. So 12 people signed up to play darts, and how many ways can a 3-person dart team be chosen? People can't repeat, and the order here doesn't appear to matter. They're not being put in specific positions. So again, a combination, 12C3. I don't know 12P3, so I'm going to do 12 factorial divided by 12 minus 3 factorial times 3 factorial, which is 12 factorial over 9 factorial times 3 factorial. The 9 factorials are going to cancel out. 12 times 11 times 10 over 3 times 2 times 1, which is 6. 12 divided by 6 is 2. 2 times 11 is 22. 22 times 10 is 220. So 220 ways. Okay, now I just want to point one other thing out. We said that CR is NPR divided by R factorial. Well, also true is that NPR is NCR times R factorial. And that's just the first equation manipulated. If I multiply both sides by R factorial, I would get this. So the point is that if you know permutations, N and R are the same number as, and you want combinations, then you're going to divide by R factorial. But if you know combinations and you want permutations, again, with the same N and R, you're going to multiply by R factorial. So both of those will be useful, in addition to the permutation formula and the combination formula that you already know. Okay, your assignment for tonight is worksheet 6, problems 3 to 7, and pages 4 and 5. Do those for tomorrow.